All right, let's go live here with Assimilate-Python. I'm going to dive into the multiprocessing module and get into a little bit of what we can do with the multiprocessing module. And to start with, I'll just add a little note here that says multiprocessing. And a few things to point out about multiprocessing is that we should probably get the docs going. So Python multiprocessing. And here we go. So let's put these into the README. We can just say reference multiprocessing. Here we go. Multiprocessing official docs. And I think one of the things that's kind of fun to play around with multiprocessing is really some of the ability to map a function to a unit of work. That's really what I think is kind of cool about this. And I mean, this is not a bad one right here. In fact, I guess what I could do is create a directory here. We can just say make dir, or actually let's put it into my lib here. That looks like a good location. So we'll just call this touch my lib, and we can call this one maybe like pool, mp pool. Let's even just take this basic function here, and we can play around with it. So what is again kind of cool about this particular example is that it's pretty straightforward. You see that all you do is you import the multiprocessing module, and then you apply a function to a pool. So you're basically saying, look, I'd want you in parallel to these 5 processes that I launch. I want you to map these 3 different inputs into each one of these. And what it should be doing, if I remember the documentation correctly, is that the pool will allow you to spawn 1 process per action. And so let's go ahead and try this out. Let's do a make format here, or make refactor. There you go. It lints it and cleans it, and it says useless method. Let's just get rid of that real quick. And let's see, that's on line 13. Forget if you can just put a comment, island disable equals useless parent delegation. Does that work? There you go. We ignored that one. Okay, so if we go through here and we say Python my lib, oops, let's run this again. Python my lib mp pool. There we go. Each one of those was multiplied by itself. Now, what would be kind of cool is to, I suppose, see if we can watch the processes spawn here at the same time. And I guess in order to do that, what could I do? I could basically do this, right? So I could run htop. So if you see this thing, we should see a bunch of Python processes spawn real quick. Although I guess, can you filter search? Let's see, F3. Whoops, let's do control F3. Option F3. I get this thing to, oh, there we go. Search for Python. There we go. And if I look for, I probably have to make it a little bit beefier than this in order to watch the Python processes all come up here. So what we could do is just add maybe like a sleep or something like that. Let's go through here and we'll say import time. Let's just say time.sleep. And we can just say like 5 or something like that. So this should make it hang out a little bit longer. And then do we see the Python processes here? Yeah, I'm not sure why this is not searching a little bit better. Unless I did a search for .py. How about that? There we go. It's kind of hard to read though with this command in the way, but let's try one more time. Don't know if I can read where the Python is, but basically in a nutshell, you could also do this. You could say ps-ef rep.py. And you can look at the Python. There's probably some way for me to see all the different processes that are happening at the same time. But the core idea here is that you're able to essentially map a function to a process. So it's okay, right, that we can do this. So again, we say make refactor. But let's go ahead and manipulate this a little bit more by doing something a little bit more heavyweight with multiprocessing. So we know that it's just a function and we map it to a pool, but I think a fun one to play around with is k-means clustering. And so a couple things that we can do here is we could build out like a multiprocessing tool. So let's go ahead and say touch my lib, and we'll call mp tool like this. And what we could do is basically build out a bunch of like fun things in here that help us play around with multiprocessing. I think we want this. So we'd say a k-means clustering tool that uses the multiprocessing library to get the process the Python click tool library allows us to create queries. Okay, do queries that parameterize process. There we go. So first up, we'll just say import click. We'll also from multiprocessing imports, I think pool is one. And we also want to do the CPU. I always forget the CPU. I think it's like Python C dash Python multiprocessing. Depending how many CPUs you have. There we go. Multiprocessing CPU count. So we can say there we go. That's exactly what I want. And let's build a function here. Build a function to return CPU count. So get CPU count, right? I mean, do I even need a function? Not actually. That doesn't really get us anything. But we could do a click group that does this. So we can say at click.group. And then we can say clustering tool. There we go. And now let's just build a quick command that that says, CPU count. Let's see here, CPU count. It's the easiest way to do this. CPU underscore count. We'll just do CPU count like that. And this one's going to be easy. And we can print the CPUs on the system, but let's color this. We can just say print it using click colors. There we go, CPU count. And then let's invoke this thing. We can come back to that one. So we can if name, there we go. So we got this thing. So again, I'll do a make refactor here. to refactor our code. There we go. Looking good. What does it say? Oh, unused pool. Well, we can deal with that one later, but we can just try this real quick. And we can also say chmod plus x lib and np tool. And then we can do, here we go. User bin env Python. And if we say mylib np tool help, we see a k-means clustering tool that uses multiprocessing to speed up the process. Great. Now, if I want to just see real quick how many CPUs, boom, there we go. We have 16 CPUs. So that is useful to know because, again, this is a pretty beefy machine here, because potentially we would want to use that when we do clustering. And so what I want to do next is I want to build a clustering like function. So build a k-means, so create a k-means clustering function that uses sample data. I think I've done. I have an example here. If this can't find it, I've got one. I can just grab it real quick in my personal account here. Let's go for k-means. There we go. K-means exploration. I'm gonna use my own. No, not that one. It would be, I think it's maybe concurrency. Let's see. In this user, see if I can find anything code. I think this might be it. Yeah, this is it. So parallel k-means. Okay, so if I grab this stuff, let's take a look at this. So we want to just steal, I'll just steal my own work here. And let's start with that. Let's just grab this over here. And let's just do this. So let's see, we got from scikit-learn. Data set, no, did I install scikit-learn? No, I need to install it. So I need to do that. Data science. And if I remember correctly, this requirements file, I guess it was just scikit-learn, that's it. So we'll go back to this, say make install. All right. And then if I say pip freeze, I don't even know what this means. The Python packaging world is always an adventure, not in a good way. Okay, so we got this, and we got this multiprocessing, and then this is scikit-learn stuff. So I'm going to say do k-means. So k-means clustering on generated data. We're going to take the number of samples. We assign some random states, and then we say 3 clusters for 3 centers, I believe, and then we want to print out the cluster fit. And then if I go back to this example here, we can say run parallel. So this is where I want to use that map stuff here. So let's do that. So let's say run everything, count, time. So it is true that I'm going to measure the time here, which is nice. And now this I do want to change a little bit. So I'm gonna parameterize this. So I'm gonna say count equals int count and processes. We can do that. So processes, processes. So basically it's going to say with the pool, map this function above here. Performed this many counts using process total. Okay, so now that we've got this thing set up, we can try to refactor it real quick to see what's broken. Import scikit-learn data sets. Great. They changed things here. Let's Google that. So sklearn datasets. Datasets. So load breast cancer. We need to look for the generated datasets. Make blobs. So from scikit-learn datasets make blobs. So from scikit-learn, that looks like it is there. Scikit-learn datasets. Import error. Did I do a make install? Bummer. Let me try that out in Jupyter Notebook or in IPython. So let's go through here. Let's say do this. We'll say import scikit-learn. From scikit-learn datasets, import make blobs. Does that work? Okay. So maybe, so I don't get this. How does that work? But this doesn't work. From scikit-learn datasets, make blobs. Unless lint, maybe is there a linting problem? Which lint? Not sure if I say make refactor one more time. Some kind of weird error. MP tool unable to import. Yeah, I don't know why I can't import that unless scikit-learn has a problem. So let's just try it out. I'm sorry, Python has a problem. So let's just say do the same thing here. We have shebang line. We have all that stuff. Let's go to this. That module named scikit-learn. Pip install scikit-learn. Are you satisfied? Very strange. No module named scikit-learn. Maybe this is like a weird scikit-learn or something. I don't. Let me go to the Python packaging repository and take a look at this. So go to PyPy and we'll go to sklearn. Oh, depreciated package. Thank you. That's awesome. What is this? Pip install scikit-learn. Okay. No clue why you're doing that to me, but sure. There we go. So we'll do this. So pip uninstall scikit-learn. Let's say make install. CPU count. And then we have help. Perfect. Now that we've got this, if we say make refactor, possible unbalanced tuple, right says that's 3. That's strange. Line 16. Possible unbalanced tuple. Right? That's 2. Unbalanced tuple packing. K-means. I guess I'll have to try that out real quick. So we'll go here. Man, all kinds of weird stuff's happening. So we'll do this. We'll just say from scikit-learn, and then we can do number of samples. Just say centers is equal to 3. Features is equal to 10. Random state is equal to 3. So now, if I just run make blobs, let's just see how many tuples do come back. We could say in samples, centers, in features, random state. It's 0 to 2, but 4 were given. 0 to 2. So maybe I need to look at make blobs now. Maybe they changed everything up. Number of samples, number of features. Number of samples, number of features. Centers equals 3. Well, let's just try this exactly. Let's try that. Okay. And then if I say return here, if I do this, is that a false positive from pylint? And it's not. It is a false positive. So thank you, pylint, for giving me, putting me down a rat hole, which is weird. So I'm going to ignore this error here. So I think I would do maybe on top of this, pylint disable that. Let's do in refactor. Okay, we got that cooking. And now we want to go help. Okay, so now we can probably turn this into a tool. So let's build another one. It says run. Run. I don't like run. I think cluster would be better. And there we go. So number of k-means clusters to run. I would say the default would be the number of CPU cores. The count, which does make things, well, yeah, I don't know how to do that. So I'm just going to say, we know that this thing has 16 cores. So I'm just going to say 16. And the processes, oh no, number of count, number of k-means to run. Oh, I see. No, I guess you can do that. You can say CPU count. So each one would be in a separate process. I like this. CPU count, CPU count. I didn't know you could do that with click, put a function in there. And then we do this, run k-means clusters on generated data. And then we can just say example and something like that. There you go. So let's just run this now. Help another thing, this cluster. And now to make it more exciting, I'm going to make a new terminal. I'm going to throw it up here. And I'm going to run htop like that. And then I'm going to do cluster. Actually, before I do that, let's just do a refactor real quick. Just see if I have any bugs. Maybe I don't. Let's see. There we go. And boom. Not bad. All right. So we got a good little tool here. I'm going to call it a day. I did some good work. Let's check all this stuff in. We get add here. And adding working code. Right. Well, another problem solved with Assimilate-Python. See you in a couple weeks.